Welcome, indie game developers! Hard to believe it's been 4 years since my last video, but I'm back with a new beginner's guide after getting a working CMake build for a new web-based game project I'm working on. The build combines using the FetchContent module to retrieve external dependencies, specifically SDL, with support for both a desktop build and a WebAssembly build using Emscripten. I have a working skeleton project over on my CMake Testing Grounds repository on GitHub, which illustrates how to combine CMake, SDL, and Emscripten. You can take a look over there to see how I organize the build script and source code. I also posted an article going over all of the details over on the game dev section of my website at rileentertainment.com. Getting to that endpoint, however, took me through a few days of pain points. By the end of this video, I hope you'll be able to avoid going through some of the same pain, and be able to confidently start your own web-based games. Emscripten is a compiler toolchain you can use to compile C++ source code into WebAssembly. If you're new to WebAssembly, a good analogy is to think of it as Java bytecode but for web browsers. It's a portable binary format that runs in a virtual machine inside the browser. You can read all about it over on the MDN website. Many web-based games are built using WebAssembly from C++, and Emscripten has become the de facto standard toolchain for this purpose. Emscripten provides direct support for many of the libraries used in game development, such as SDL, OpenAL, and WebGL. In fact, when you are building with Emscripten, your WebAssembly build targets are actually using Emscripten-specific versions of those libraries. You'll also need to be aware that using Emscripten does affect the way you code your game's main loop. I'll discuss the impact on your source code a little later, after discussing how to set up your CMake build scripts. Emscripten is fairly easy to install. It's available as a Git repository on GitHub, and they have clear installation instructions over on their website. You can clone it to a DevTools folder of your choice, and then run these two commands to install and activate the latest toolchain. This process doesn't set up anything in your system registry or your PC's environment variables. You could do that if you want to, but there are quite a few environment variables to set up. For Windows users, Emscripten provides this batch file, which you can run on the command line before running your game's build. If you're using Visual Studio for your development, you can make it aware of Emscripten by running the native tools command prompt, running that batch file, and then running devenv to open Visual Studio. If your project is only targeting a WebAssembly environment, you don't actually need to build SDL yourself. For my project, I want to target both WebAssembly and the desktop, so I'm going to discuss building SDL for the desktop first. When I'm choosing which C++ libraries I want to use for my projects, one of the major determining factors is how well the library supports fetching it via the CMake FetchContent module. For projects that grow beyond needing only a few dependent libraries, you'll probably want to use a package manager like Conan, rather than the CMake FetchContent module. A secondary factor that determines my choice is that the library have an official release tag. I was hoping to use SDL version 3, but what held me back was the SDL mixer library, which I'd like to use to load and manage music for my game. As of the time I started my project, the latest release tag for the SDL mixer library was still targeting SDL version 2. But it looks entirely possible that by the time I release this video, they'll have their first version 3 release. My timing on this led me to choose to stick with SDL version 2. SDL's CMake build scripts do play fairly well with the FetchContent module. However, there were a few pain points I had to work through. When I'm figuring out how to link my own C++ projects to a new library, I like to look through its CMake build script first. There are 3 main things I'm looking for. First, I like to find out how to build it as either a static or shared library. My preference is to build dependent libraries static, so that I don't have to package its binaries as separate files with my own release, or rely on the end user already having the library. Second, I look for all of the option statements to find out which CMake variables I'll need to set, based on what functionality I need from the library. The SDL image library is a good example of this, since for my current game project I only need support for JPEG and PNG formats. And finally, I check to see if the library has any dependencies of its own, and if so, how it goes about linking to those dependencies. This led to something of a pain point with the SDL image and SDL-TTF libraries, as both have dependencies of their own. If you look at how the SDL-TTF library's CMake script finds its free type dependency, for example, you'll see this block. It's common for libraries to use the term vendor to describe a dependent library that is included in its own source tree. So it either looks for it in the external free type folder, which is the vendor approach, or it calls find package, which uses the free type library already installed on your system. What I didn't realize is that the SDL Git repositories have Git submodules for their vendor dependencies. Git submodules is not something I make use of very often, so this oversight on my part led to several hours of pain. You can quite easily deal with this by adding the Git submodules property in your FetchContent declare block, specifying the folders it needs to clone. This particular pain point was exasperated by this policy change in CMake as it relates to Git submodules. Prior to CMake version 3.16, you could specify the empty string to clone all submodules. But I was using version 3.24, so the empty string was not cloning any submodules. The compiler and linker errors you get if you miss this are not very helpful, so it's easy to end up in a spot where you're spinning your wheels. When you invoke CMake for your Emscripten build, it sets this Emscripten variable, which you can query in order to split your build's logic. The Emscripten part of your build doesn't need to build SDL itself, but it does need to tell the compiler and linker what version of the SDL libraries you want. Emscripten provides WebAssembly ports specific to SDL. On the Emscripten website, you can find the compiler and linker options you'll need in the Tools reference under Emscripten Compiler Settings. The way I've chosen to define these settings in my project's CMake build script is through the target compile options and target link options commands. Using these commands ensures that they apply only to the specific build target. Getting these options exactly right was another pain point for me, as once again the compiler and linker errors you can get aren't very helpful. If you're building a web-based game, you're likely going to want to package some graphics and sound effects with it. On the Emscripten website, you can find documentation for this under Porting, then Files and File System, then Packaging Files. A WebAssembly package bundles up all of the desired files together, making them available while your game is running in a virtual file system on the web browser. This preload file option provides a simple way to package all of your assets together. The @ symbol is used to specify the target subfolder in the virtual file system. So for this example, we're copying all files in the source resources folder into a resources folder in the WebAssembly virtual file system. Source code can then reference a specific file by looking for it in that same resources folder. To run the Emscripten build on the command line, you first set up the Emscripten environment. Then configure the project with emcmake, cmake-b, then the path to the desired output folder. And build the project with cmake-build, and the path to the output folder. Once this is all done, you'll find 3 files in the output folder. A WASM file containing the web browser compatible bytecode, a data file containing the virtual file system with your packaged assets, and a JavaScript file used to bootstrap the WebAssembly bytecode together with the canvas element on your web page. You can optionally tell Emscripten to include an HTML page in its output with a setTargetProperties command like this, which can be useful for debugging. But if you're building a web-based game, you're also likely going to want a custom HTML page that integrates into your website. Currently, the JavaScript code that Emscripten produces puts some requirements on how your HTML page needs to operate. First, it must have a canvas element, and the path of least resistance is to set its ID attribute to the exact value canvas. Second, it makes use of a globally scoped variable named module, and again the path of least resistance is to set a property on this variable named canvas to refer to the canvas element. If you're using modern JavaScript practices, you're probably coding your script tags with the type module and initializing your page using the DOM content loaded event handler. The Emscripten JavaScript needs to see the canvas element in your document tree. So my approach to ensuring there are no race conditions using modern JavaScript practices was similar to the following. I include a small script tag with type text JavaScript to ensure a global module variable exists. Set the canvas property on that module variable in my DOM content loaded event handler, and attach the Emscripten JavaScript script tag dynamically after this in the same event handler. Emscripten provides a number of C header files that you can conditionally include in your game's code using this Emscripten preprocessor macro wrapped with 2 underscore characters. There are several C functions available that you can call to set up your game's main loop. I suspect most small game projects will want to use the Emscripten setMainLoopArg function, which lets you pass in a user-defined pointer for your game's state. If you're targeting both the desktop and the web, your game loop will probably look something like the following. And in your game's callback function, responsible for handling events, updating game state, and rendering, you'll need to typecast this user-defined pointer to the structure encapsulating your game's state. I did encounter a few minor pain points related to my first experience programming with SDL. At first, my sample code was calling SDL wait event instead of SDL pull event. The former will cause your web browser to hang since it blocks waiting for input. SDL pull event is what you'll want for a game anyway, but this can easily be a pain point when you're just trying to get things working for the first time. Another issue I encountered was related to the lifecycle of the SDL systems. You need to ensure that all SDL systems are initialized before creating a window, renderer, or any of your assets like textures or audio. And you need to ensure that all of your assets, the window and the renderer, are destroyed before the teardown of the SDL systems. In my case, I had a copy-paste error in my game's destructor, where I was freeing the wrong mixed chunk sound effect. This bug manifests itself as an error in one of the SDL quit methods later, which makes tracking down the cause difficult. It's exasperated by the fact that the error wasn't consistent, only happening once every few runs of the desktop build. You can avoid this problem by wrapping your assets in a C++ class, taking advantage of the resource acquisition is initialization concept. I hope this video can help a few aspiring indie game developers make their way through getting their first web-based game successfully building with CMake, SDL, and Emscripten. You can find the sample project over on my CMake Testing Grounds repository on GitHub. I also have a project page in the game dev section of my website at rileentertainment.com, where you can play the silly Hit the Gopher game from the sample. I plan on writing more articles related to SDL, Emscripten, and game development in general, and producing more companion videos here on YouTube on topics like handling window resize events, handling mouse and touch events, and loading asset files from URLs. So stay tuned to Riley Entertainment Games and smash that like button or subscribe to my channel if you found value from this video.